Welcome back. Today we're going to be talking about the volume of prisms. So students will be able to find the volume of prisms. Language objective students will be able to discuss the steps required to finding the volume of a prism. Why am I learning this? Well, it's important for real-world problems like finding out how much water it would take to fill up a tank. So our central question is, how can geometric facts and formulas be used to solve real-world problems? So first of all, some background knowledge. In the 6th grade, you learned how to find the volume of rectangular prisms. You would multiply the length times the width times the height, right? So that is one way to think of it. Now, we are going to be using something slightly different this year because it's going to be able to be applied to different types of shapes other than just rectangular prisms. So, how would you find the volume of a shape like this? Would you still do length times width times height, or maybe a shape like this? Could you still do that? The answer is no. Okay? It will not work for these types of figures, and that's why we're going to adjust this formula a bit so that it can work for any type of prism. So, before we get to that, why do we learn about volume? Well, finding the volume of a figure tells us how much space is available inside the figure. So, for example, how much water it would take to fill up this tank, this water tank, that would be the volume of that. Okay, or possibly how much concrete would be needed to fill up this rectangular prism, okay, which basically is a little enclosed area. Again, this would be a volume problem, is figuring out how much space it would take up. So volume of prisms. First, we are going to adapt it, and this is how we will adapt it. The volume, the formula for the volume of prism is now going to be adjusted to just the area of the base times the height of the figure. Now, to write it shorthand, we are going to refer to the area of the base as a capital B, and yes, it has to be a capital B. So this is going to refer to as the area of the base, and the height of the figure, we are going to use the word altitude. Why? Because if you use the word height, you're going to see with some of the examples, it's going to be confusing because you're going to wonder, okay, the height, there's going to be two different heights. So we are going to use the word altitude. So quickly, for short, the volume for a prism is now going to be used as a capital B times the altitude, ALT. So, let's do a rundown of background knowledge. Remember, prisms, they're basically named off of the base. So here, since the base is a square, it's a square prism. Here, since the base is a triangle, it's a triangular prism. Same thing with pyramids. The base definitely describes the type of pyramid. So, since the base is a square, it is a square pyramid. Since the base is a triangle, it's a triangular pyramid. For cylinders, technically you can kind of think of it as a circular prism, but it does have a special name. It's called a cylinder. It can also be referred to as a right circular cylinder. Same thing with a cone. If you use this kind of pattern, you would think of it as a circular pyramid, but it has a specific name. It's called cone, which is sometimes referred to as a right circular cone. So, what defines a base? It is a base if, okay, first of all, in a prism, there are two of them, and they're always the same. They're congruent. So, for a prism, there are two congruent bases, but what else has happened? They have to also be parallel to one another. So in this case, these are our bases. You can see that they're identical, but they're also parallel. So we've talked about the base, but what about the altitude? Because that's also used in the formula for the volume of a prism. The altitude basically describes how tall the shape is. So how tall is the shape would be this line here, or this line here, or this line here, or this line here. Basically, the altitude describes how tall it is. So, what shape could the base be for this? So remember, the base there has to be two congruent ones, and they have to be parallel. So in this case, it would be a triangle. So because it's a triangle, it is a triangular prism. So where is the altitude? The altitude would be right here because it tells us how tall this prism is. So we can use any of these. It would still describe the altitude. Now, what about this one? Well, again, they have to be parallel to one another, but they also have to be congruent. So here I would say that the base is a square or a rectangle, okay, because this one could be thought of as both ways. You can push this on the side. And what would the altitude be? Well, depending on what you consider the base, the altitude is going to change slightly, but in this image of this one here, I would consider this to be the altitude. Again, you can also use this here or this or this. They are exactly the same. And what about this one here? So here, I would say that the base is, yet again, a triangle. Why? Because there are two of them, and they're identical, but also they are parallel to one another. Now, some of you may argue with me and say, well, those two triangles don't look congruent. Well, that's because it is the perspective of the image. If you were to look at it straight on or possibly have it in your hand, you could possibly notice that it is actually congruent. So please understand that the drawings, because it is a three-dimensional figure drawn on a two-dimensional plane, it will lose some of its features. Okay, so here, what is the shape of the base? I would say a triangle, because there's two of them. You know, you can't see it, but it's one over here and one over here. They're parallel and congruent. The altitude would then be this here. Okay, so this looks a little strange because height, you're used to having the line go up and down. So in certain cases, depending on how the prism is oriented, it will look slightly deceiving, I guess you can say. So here, what would the base be? Well, the base would be a circle. What's the altitude? It would be the height of this, so that would be the altitude. Here, what is the base? So this one would be a, let's see, how many sides are there? There's 1, 2, 3, 4, 5, 6. Since there's 6 sides, this is called a hexagon, so the base is a hexagon. Well, what's the altitude? Again, it's basically describing how tall it is. Okay, so with that said, let's go ahead and start practicing here. Number 1, it says to write the name of the prism and then find the volume. First, it's important to understand what the base is. The base would be these two shapes here. I know that this is the base because there's two of them, and they are congruent. Since this base has 1, 2, 3, 4, 5, 6 sides, this is called a hexagonal prism. Okay, so I'm going to go ahead and use my formula, which is volume equals the area of the base, which is used by a capital B, times the altitude, which is another fancy word for height. So, what is the base? The base is a hexagon, which they already told me the area is 40. So I'm going to replace with the area of the base is 40 units. I'm going to multiply by the altitude. How tall is it? Well, it's 7. So I'm going to go ahead and multiply by 7. So this is it. 40 times 7 is 280. And it's going to be units cubed. With volume, your units will be cubed because it's measuring a three-dimensional aspect of it. Okay, and that's all there is to it. So let's move on to the next example. For number 2, again, the first thing you want to do is identify what kind of prism is it. Well, I'm noticing here that the prism is a trapezoidal prism. Why? Because there's two trapezoids that are congruent and they are parallel to one another. So let's write that down. It is a trapezoidal prism. And again, the name is derived from the base. So once again, let's find the volume. We're going to first do that by finding the area of the base and then multiplying by the altitude. Guess what? They told us the area of the base, which is really nice. They told us the area of the trapezoid is 354. So I'm going to replace B with 354. And then how tall is this? Well, this here is 4 units tall. So I'm going to replace that with a 4. So all I have to do is multiply these two together. Let's do some side work. So we have 1,416, but you have to put units. And hopefully you guessed it right, it is going to be cubed because it's volume. So we always write our units as cubed. Okay, number 3. So first things first, let's identify what kind of prism this is. Well, here there are 2 of these shapes. So that must be the base. And again, the base is what describes the prism. It's basically is responsible for naming it. So since this base has 1, 2, 3, 4, 5 sides, this is a pentagonal prism. So we're going to go ahead and find the volume by first finding the area of the base, which we use a capital B, times the altitude, which again is just another fancy word for height. So here, what's nice is they already gave us the area of this pentagon. They said the area of the pentagon is 147, so that's going to replace the area of the base. Now, how tall is this? Well, this is 2 units long, so I'm going to go ahead and multiply that by 2. Now to simplify, I'm just going to do some side work. 147 times 2 is 294 units cubed. And again, don't forget to put cubed. So that is our answer. Okay, number 4. So what do we do here? Well, first let's figure out what kind of prism this is. It is the shape of a, you guessed it, a triangle. So for that reason, this is called a triangular prism. So to find the volume, what we're going to do is find the area of the base, which is used by capital B, times the altitude, which is another word for height. So again, what's nice is they already gave us the area of the base. The area of the base is 63. So we're going to replace B with 63, and then we're going to multiply by the altitude. How tall is this? Looks like it here. It is 8 units tall. So we're going to go ahead and multiply this in our side work, which gives me 504. But let's not forget, we do have to put units cubed because that is a measurement of volume. So it is cubed. Okay, so number 5. Now they're kicking it up a notch. Why? Because they didn't give us the volume of something, so we're going to have to figure it out ourselves. So here, I'm going to go ahead and shade these two and say that this is the base. Okay, so which means this is called a rectangular prism. Okay, so with that said, what I'm going to do is use the same formula. The volume is going to be determined by finding the area of the base and multiplying by the altitude. So here's the thing. We don't know the area of the base. They didn't give it to us, but guess what? We know how to find the area of a rectangle. So I'm going to do a quick sketch. This rectangle is 10 by 5. How do you find the area of this rectangle? Well, simply do 10 times 5, and that's 50. So the area of this rectangle is 50. So I'm going to go and replace B with 50. And I'm going to multiply it by the altitude. What is the altitude? Well, it is 7 inches tall, so I'm going to multiply by 7. And this is going to give me 350, but this time I'm going to write inches cubed, and that would be our answer. Okay, what about number 6? Again, it's going to be a good idea to first start with what is the shape of our base. Okay, the shape of our base is a trapezoid. So that's good to know because now I'm going to write my formula. The volume, forgot, let's name it so that we know. It is a trapezoidal. Okay, so we're going to find the volume by finding the area of the base, and we're going to multiply it by the altitude. So here again, what's unlike the other examples, they didn't give us the area of the trapezoid, but it's okay. We should know how to find it. So here is a rough sketch of a trapezoid that I have. It is 11 here. Right here is 4, and this is 6. Okay, so it looks like they gave us some extra information, so we need to be careful. To find the area of this trapezoid, you're going to do 1/2 times the 2 bases. Okay, so here I'm missing a length here. I need to know what this length is, so I'm going to refer back to this. Well, it seems like it is 5, so I'm going to go ahead and write that down. So we're going to find the area of the trapezoid by taking both bases, which is a 5 and an 11, and then I'm going to times it by the height. Well, the height is 4. So here is a great example why you don't want to use height here, because here we're using height, so it would be confusing to use height here and height here. They're different. So area is going to be 1/2. Here it's going to be 16 times 4. And then we're going to do divided by 2. Here, to make things easier, I am going to just go ahead and cross cancel. I'm going to cross cancel with the 16. So I'm going to get the area is 32. So here, what is the area of the trapezoid? It is 32. Now, how tall is it? Well, technically, the height of it is represented by this value here. So it is 8. So what is the volume of this trapezoidal prism? Well, let's figure out what is 32 times 8. It is 256, so I'm going to go ahead and say it's 256. There are no units, so I'm going to go ahead and just say units cubed. So for number 7, what am I going to do? Well, first figure out what the base is. Hopefully you recognize here that the base is a triangle, so this is a triangular prism. Ooh, I wish I can spell. Okay. So first things first, we're going to start with our formula. The volume is going to be equal to the area of the base times the altitude. So since the base is a triangle, I'm going to find the area of this triangle. Now pretend I drew this perfectly because I know that it's not, but here this is 3 and this is 8, and this 4 is referring to this, so I don't have to really write it. So what's the area of this triangle? Well, it's 1/2 base, which is an 8, times the height, which is a 3. Now, I can't cross cancel between 2 and 8, so I'm going to go ahead and do that to make the number slightly smaller. 2 divided by 2 is 1. 8 divided by 2 is 4. If it helps you, you can put it like that so you can see. So I'm going to get that the area is 12. So what is the area of the base? The area of the base is 12. And the altitude, well, how tall is it? It's 4 feet, so I'm going to multiply by 4. So 12 times 4 is 48. I'm going to go ahead and put feet cubed. So that is the volume for the triangular prism. Okay, last but not least, so I know this looks a little intimidating because it looks different, but same thing applies. Well, first of all, they told us it is a triangular water tank, so obviously the base is going to be a triangle. So that's helpful. They told us that this here is 53 inches, this here is 31 inches, and that is 8 inches. So what am I going to do? Well, I'm going to start with my formula. The volume is going to be the area of the base times the altitude. What is the shape of the base? Again, the shape is a triangle, so we're going to say the area is 1/2 the base, which in this case, let's call it, it really doesn't matter, 38, times the height, which is 31. So here I can go ahead and cross cancel if it helps. Again, you can put it over 1. You can cross cancel by the 2. And this is going to become, I believe, 19. So what is the area of this water bottle? Well, let's figure that out. 19 times 31. Going to be 589. So what is the area of the triangle? Well, the area of the base, which was the triangle, is 589. Times the altitude. Well, how tall was this? Well, it's 53. So we're going to have to multiply that out. So here I have some room. So we're going to put inches, and again, hopefully remember it is cubed. So what's the volume of this triangular water tank? Well, it's 31,217 inches cubed. So guess what? That actually concludes the lesson for today. Thank you so much for tuning in, and as always, until next time, bye.